Okay, now let's get started. We're going to start with a little bit of revision. What's important to know for today's lesson. Okay, so now I'm starting. Okay, now can anyone remind us what this is called? The black lines with the two number lines and a Y and an X and all of that. What do we call this? Yeah, that took all of 0.5 seconds. That's a Cartesian plane. We have two axes. Please give me the names of the two axes, guys. X, Y axis. I like how focused we are. It's like we never left. I love it. Right. And then what do we call these dots over here? Let's see if we remember that. What do we call the dots that are contained on the Cartesian plane, which we have so nicely reminded me? What do we call the dots, guys? They're not dots. I promise you it's not a trick. They're not dots. So this is a Cartesian plane. My handwriting is a little bit wonky today because my hands are freezing. Coordinates. Okay. Lately, dancing is my thing when I'm happy. Okay. Used to be singing, and I think dancing is a better option because singing was a little bit destructive. It'll kill you guys. Okay. So they're coordinates. Okay, so we have your Y and X axis. Let's remind everyone who might not have been here or who forgot because it was holidays. Okay, so on the left of our X axis, the X axis is the horizontal one. Okay, the one that has X next to it, it's labeled X. That will be our X axis there. And on the left of the zero, does anyone know what we call that zero? This point here by zero, right in the middle. What is it called? Definitely never go. What is that called, guys? It has a name. It's not zero. The origin. Thank you, Tanseng and Komoto. Thank you, Narato, and Aya, and Abukan. Ooh, it is the origin. So on the left of the origin, we have a negative X coordinates. On the right of our origin, we have the positive X coordinates. And now we're talking about the Y. Above the origin, we have the positive Y coordinates, and below we have the negative Y coordinates, right? Now let's remind each other, how do you find points? What are the coordinates of A? What are the coordinates of A? Let's see. Is that how we write our coordinates? We are cheating me. Anya, I hope I can hear you through your blanket. Yes, Anya.
Open brackets.
There we go. Anya's off to a good start. Open brackets.
1.
1.
Semicolon. 1, then close the brackets.
So both my coordinates are 1. Anya, are you sure?
Yes, I'm sure.
Let's discuss it with everyone. Guys, let's discuss these coordinates. Remember, okay, I think I first have to remind us how coordinates are written. First, you have a X coordinate, or open bracket, X coordinate, semicolon, your Y coordinate. Now, I don't quite agree with Anya's analysis. Okay, some of it is correct, but not completely. Let's see if Palisa knows why. Palisa, do you agree with Anya's coordinates?
No, ma'am.
Okay, what do you say the coordinates for A are?
Ma'am, I would say it's 0 is to 1.
0 and 1. Thank you. I agree with Palisa, guys. Anya was partially there, but Anya has forgotten important stuff. Okay, remember, when a coordinate is on the y-axis, that means the x has to be 0, guys, because it is literally on the origin. Can you see that? So it has to be on the axis. So our x coordinate is 0, but we've established that our y has to be 1. I hope we all remember how to find these coordinates now. Abu has already given me the coordinates for B. Abu says B is 1 and 0, which would be correct because this point is on the x-axis, which means your y-coordinate has to be 0. So your x is 1. You can see it clearly there, it's on the 1. But because it's on the axis, it would be 0. Okay, what is my coordinate for C? I see a lot of messages that I look like I've missed. My coordinates for C, where is C? Okay, I'm hoping Jason just can't find the correct brackets, but he is. Let's see. Okay, for C, we would have 5 on the x-axis and 1 on the y-axis. I see hands going up. Nitabi saying. Yes, Nitabi.
I just have a question. Does it matter like what way you put it in? So like, do you have to put the number first? Does it have to be y first and then the comma and then you have to do x, or does it have to be x first and then the comma and then the y first?
It's x first. Can you see over here? I wrote it down in red. That's always your x coordinate first and then your y coordinate. And yes, it matters because let me show you why. If we swap, look at A and B. Can you see A and B are basically swapped around?
Yes, ma'am.
Are they in the same position?
No, ma'am.
Exactly. Do you see why it's important?
Yes, ma'am.
Because if I tell you, let's say I tell you I have a coordinate and it's 2, let's say 2 and 4. So if I say 2 and 4, that means x has to be 2. So you know where to look. You look on the x-axis and y has to be 4. So you look at y-axis and you plot it over there. If you swap them around by mistake, that means your x will be 4 and your y is 2. Can you see those are 2 very different points?
Yes, ma'am.
There we go. So always put your x first and then the y after.
Okay, thank you, ma'am.
You're welcome. Okay, let's see the other raised hands. Bulelwa.
Hi, ma'am.
Hello.
I'm doing D.
D. Let's see. D. Coordinates for D.
Open bracket.
-3. -3.
Comma.
Semicolon.
-1 close bracket.
Beautiful. Beautiful, Bulelwa. Love it. Let's hear what Sia has to say. Sia. Sia. Okay, Sia's not saying anything. Palisa in the chat says E is 4 and -3. Let's see if that's correct. E is 4 and -3. And F, which is our last coordinate, is Okuhle. Let's hear Okuhle.
Hi, ma'am.
Hello.
It's -3, semicolon, and 6. Close brackets.
Is if, oh, there it is. -3 and 6. Thank you, Okuhle. Okay. So we remember how to find points and probably how to plot them, right? Now, we're going to look at types of graphs. Linear versus nonlinear graphs. So a linear graph, A, it has a constant difference between the terms, and B, the graph is a straight line graph. So constant difference and straight line. Those are 2 ways to identify a linear graph, okay? So if you don't have, a graph in front of you, you can look at the points and see if they have a constant difference, okay? So that would mean that a nonlinear graph does not have a constant difference. So it's just the opposite, okay? It does not have a constant difference, okay? And then the graph will have a curve or change in direction. That was terrible. Or change in direction. there are two conditions. Okay, a lot of us remember the curve part, but we forget the change in direction. I'm going to leave this here for 2 seconds for you guys to take screenshots. So reminder again, linear graph has a constant difference and is a straight line graph. Non-linear graph does not have a constant difference, can either be a curve or it changes direction. If you're on your laptop, you take a screenshot by pressing PRTSC, and then you open any Word document and you paste. Okay, Karish. Yes. Hi, Karish.
Hi, ma'am.
Do you have a question?
Yes, I have a question, madam.
Okay, let's hear.
Madam, can we record the video and look at it later? Because hello, ma'am. Ma'am.
The cat looks like she's a little bit frozen right now, but yes, all of our lessons are recorded. You can find them either on our Watobe website, or we also have a YouTube channel, in case you didn't know. So all of the lessons that we've done this year so far are recorded and are put up on those two places. So any of the lessons that you want to go back and look at, you can go and watch the videos again later.
Okay, ma'am. Thank you.
Thank you.
Thank you.
Oh, there goes Miss Cat. Okay, guys. Let's give Miss Cat a minute or two to get back.
I'm back. I don't know what happened. I'm back.
There we go. There we go.
Now I don't know what you guys heard and what you guys missed. I don't know.
I answered the question that was asked, and yeah, that was it. You were literally gone for a minute.
Wonderful. Screenshots. Okay, let me go up for the screenshots. Quickly screenshots. Remember, on the laptop, it is PRTSC. Few seconds to screenshots. Any other questions? Feels like, sorry, I'm late, network problems. Same Z's. Okay, I'm almost done with the screenshot. Let's go back. So is the following graph linear or non-linear, right? So remember the two conditions for linear graphs. Komodo already says non-linear. This is a graph that represents the distance traveled by a car. Okay. There are 75 of us in here, so I'm expecting way more answers than I'm seeing right now. Non-linear must be a constant line. Non-linear. This graph is non-linear, okay? That's fine. Looks like everyone is saying non-linear. Can you give me a reason for why it's non-linear? Let's hear if we know why. Let's remember our conditions. We're saying this is non-linear. It's curving. That is beautiful, guys. Can you see over here? It is a curve. If you are not sure, you can write down the coordinates and check. Okay, so let's look at time. 0 seconds, 5 seconds, 10 seconds, 15 seconds, right? Let's read off the graph. At 0 seconds, you have traveled 0 meters, right? At 5, you have traveled 50. See, I'm reading off the graph. At 10, you have traveled 200. And at 15, you've traveled about 450. Right, so to go from 0 to 50, how much did we add? To go from 0 to 50, yes, it has to be in meters because you're definitely not going to travel 50 kilometers in like, yeah. We added 50. From 5 to 10 seconds, how many did we add? So we added 50. Sanela says we added 150. Yes. And then from 200 to 450. 250. Thanks, Abu. Is this a constant difference? Is this a constant difference? We first added 50 and then we added 150 and then we added 250. It's busy changing, right? So if you're not sure, just by looking at the graph, write down the points. Write down the points and look, do I have a constant difference? So no, we don't, right? So this is no constant difference. So this is non-linear. Okay, see guys, different ways to check. Different ways to check. Let's see our next one. We're still asking, are they linear or non-linear? These are cars that are remaining in a lot of a salesperson's place of work. No, that was such a long sentence for nothing. Very long for nothing, guys. Is this a linear or non-linear graph? And tell me how you know whether it's linear or non-linear. Okay, everyone says it's a linear. Give me a reason. So we're saying this is linear. And I have 2 hands up. Let's hear Tabi saying.
Ma'am, I think it's linear because it's not like curving.
Exactly. It's not curving, it's a straight line. Thank you very much, Hussein. That would be correct. That was beautiful. So this is linear because it is a straight line. Okay, let's move on. Let's move on. Car sales in 2019 per month. Is this a linear or non-linear graph? Remember, you tell me the reason why you say it's linear or non-linear. Your answers have to have reasons. Hey, I love the reasons I'm getting. I am loving the reasons. We're saying it is non-linear because it changes direction. So it might not curve, but it changes direction. So that is what makes this a non-linear graph. Okay, doesn't curve, but it changes direction. Now, I want to see if you guys can recognize it when you see a table. We have a table. Is this a linear or non-linear function? Remember the 2 conditions for being linear and the conditions for being non-linear? And then tell me if this table that I have on the bottom represents a linear or a non-linear function. Let's hear what we have to say. We have 2 tables. Okay, we're saying non-linear. Okay. Ooh, let's check what Tammy says. Let's all check what Tammy says. Linear because it has a constant difference of plus 35, guys. From 20 to 20 packets sold, we added 35 brands. 70 to 105, we added 35, added 35. So that means we have a constant. So we don't need a graph to know whether it's linear or not. Since we have a constant difference, which means we're adding the same thing every time, this would be a linear graph. Well, function. Yeah, that's why I show you guys different representations. Do we remember different representations? End of the term 2, we did multiple representations where we showed how we can represent a graph as a table or a table as a formula and a graph. That's where this will come in. So you must go back. I recommend we go back and we remind ourselves of those multiple representations. Wonderful. Let's do our last table here. Need you guys to tell me whether this table is linear or non-linear. Let's hear. Linear or non-linear? See, okay, Sanela says non-linear. Ooh, everyone says non-linear apparently. Why is it non-linear? Why are you saying it's non-linear? No constant difference. Let's look at the table carefully. To go from 0 to -6, what did we add or subtract? 0 to -6, we subtracted 6. Then -6 to -8. So let's go from there to there, we subtracted 6. And then to go from -6 to -8, we subtracted 2. Already, you can tell that it's non-linear because we are not subtracting the same number. Okay, guys, and it changes direction. Beautiful, Yenzeka. Yenzeka says it changes direction. If you look here, from -8 to -6, what are we adding or subtracting? What are we adding or subtracting? We are adding. So what happened there? We went from subtracting to adding. Can you see that this is a change in direction? So A, there is no constant difference. No constant difference. And B, it changes direction. That was good, Yenzeka. Wonderful. And then you add 6, exactly. Now we're going in the adding direction. We were subtracting just now and now we're adding. Okay, beautiful. Finally, there is a brain break. I know you guys are gonna kill me if I didn't add a brain break. Okay, I nearly died. The brain break. Imagine, guys. So I need you guys to tell me how Hello's head just went bah, ready, number 1 for the brain break. Wow, look at you guys, Palisa. We missed it finally. Guys, there are 7 hands. That's more hands than we've had in this whole lesson. For a brain break, I can't believe you guys. First one, would you rather? Let's hear. Alisa.
Yes, ma'am.
Would you rather eat with your belly button or drink with your ears?
I'd rather eat with my belly button.
Ew.
Ma'am, it's
That's
more
disgusting,
disgusting with your ears.
That's disgusting. That's
Ma'am,
nasty,
imagine
guys.
having... No, ma'am. Imagine putting food into your ears.
No, but you know, we're saying if you choose the ears one, then you can eat normally. But if you wanna like drink tea or something, you're gonna have to drink it with your ears.
I still choose belly button.
Yes, you guys are gonna clog your belly button. Can you imagine in a restaurant pulling your shirt up to eat? Guys, please think carefully.
Ma'am, it's they will know that it's a kind of condition or something like that.
But this is like, I am gonna stick to the belly button. I love it. It looks like everyone is choosing belly button. Wow. Wow. Nobody's having it. It's fine. Hello.
Hi, ma'am.
Hello, hello. Let's hear yours. Would you like rather sound like a cow or a chicken when you laugh?
Ma'am, I'd rather laugh like a chicken.
Like a chicken. It's a very loud
ma'am.
laugh.
Very.
It's better than mooing though. Everyone who's saying cow, guys, how do you moo? Like everyone around you would just be concerned about you mooing. Imagine. At least like a chicken, they're like, she has a terrible laugh. But like a cow, they'll be like, what's wrong with him? Are they okay? Maybe this one needs to go to the doctor. Think about it, guys. Please think about it. Yee. Yee. I actually can't. I haven't heard Narisha's voice. Narisha, are you there?
Hi, ma'am.
Hi. Would you rather have tiny feet and huge hands or huge feet and tiny hands?
I would take the second option.
So you'd rather have huge hands?
Now I'd rather have small hands.
Small hands.
My hands are already small.
How are you gonna do anything with tiny hands?
Ma'am, my hands are the smallest in my class.
Imagine
So-
if you're fighting.
Yo, ma'am, have you felt how babies slap? Yo, ma'am, they slap hard.
Imagine picking up all your books, your bag. How's that gonna work?
But ma'am, imagine if you have to unlock an iPhone and your thumb is so big. Yo, ma'am, no.
You make the letters massive, guys. I don't know.
No.
Imagine wearing size 19. Please think about this carefully.
Oh, ma'am, no. I'll take the second option rather.
Bulala says huge hands so I can break the dishes and never do dishes. He does it terrible. Jason, imagine wearing size 19. Like, that's a serious issue. That is a serious issue. I don't know if I could be able to deal with that. I don't. Who's Messi? Let's hear who Messi is. Messi. They will be for you, Khaukhela. They will be for you. Messi. Hello.
Hello.
Oh, there we go. I heard a hello. Would you rather shave all your hair or lose all your teeth? When I say all your hair, I'm including eyebrows and eyelashes. Ne?
Lose all your teeth.
You'd rather lose your teeth.
Yeah.
You don't want to shave your hair.
Nah, my hair is too good right now.
So you'd rather drink like milkshakes and stuff.
Yeah, it's fine.
Okay. Wow, guys. Messi says drip is forever, basically. That's basically what you're saying. Guys, I would be depressed if I couldn't eat nice food. Oh my goodness. I would be so depressed. I would rather lose hair also. But your eyebrows, guys, please think about it. Like, you're gonna look so strange. Erin is like, I'm not gonna have any of this. Don't ask me funny questions. I can't. Sinesihle? Sinesihle there.
Yes, ma'am.
Sinesihle, would you rather always drink from a huge bucket or from a baby bottle?
A baby bottle, ma'am.
Have you ever been hungry from sports?
Not really, ma'am.
Been thirsty. I can tell you haven't been thirsty from sports. And then you have to drink from a baby bottle. Guys. Guys, I wouldn't be able to do that. I would rather use a bucket. I'm sorry. I am so sorry. I would rather use a bucket. I would much rather use a bucket. I'm sorry. Guys, you're not allowed to screw the top off and you're not allowed to make that hole bigger. Okay? You're not, if you choose baby bottle, you must be willing to drink from that little tiny hole that it has, like with your liquid come out. Ow, guys. So sorry. That can never be me. Imagine, must drink from your Coke is even gonna finish acid while you're drinking. Now you're there just drinking. Our guys. It's fine. I'd rather carry a bottle, a bucket, I mean. I'd rather than die of thirst. I would rather swim. Exactly. Exactly. Imagine you are thirsty, but you have to wait for that water to I'd never. Never. I would also carry a bucket. I'm sorry. Okay, I think that's the end of our brain break. And now we are going to talk about increasing, decreasing, and constant functions or graphs. Okay, the word function and graph is the same. All right. Now we are moving on to increasing, decreasing. So we're doing types of graphs basically today. Okay. Now, Mtokozi just brought up something hilarious. You know, after break sock, woo, and you must drink from a baby bottle. You guys are gonna die a real death one day, I'm telling you. Okay, let's talk about increasing, decreasing, and constant functions. So an increasing function is when the x and the y coordinates are increasing. Okay, this will cause the graph to look as if it's increasing, which means it moves upwards from left to right. Okay, so if you don't have, let's say you don't have a graph and you only have coordinates, all right, then you can look, are the x coordinates increasing? Are the y coordinates increasing? So both of them have to increase. And if both are increasing, that would be an increasing function. So a decreasing function is when they are in indirect proportion. So as the y values decrease, the x values will increase. So obviously you have to start with your input. Input is your x values. They always increase, right? Think about the graphs we usually draw. We usually draw graphs going from -2, 0, 1, 2, blah, blah, blah. And then, okay, let me fix my pen. Give me 2 seconds. Oh, it was upside down. Yee, we are tired, guys. -2, -1, 0, 1, 2. So when we draw our tables, this is what it usually looks like, right? So if your x coordinates are that, and your y coordinates are decreasing, so if this is 4, 3, 2, 1, 0, then that would be a decreasing function. And the graph moves downwards from left to right. Okay, and then you have a constant function, which is exactly that. It is constant, it doesn't increase or decrease, and I will show you what it looks like. Okay, it means one of the coordinates will remain the same. So either your x coordinate remains the same or the y coordinate remains the same. And if that happens, then that would be a constant function. Now let's see if we can identify increasing, decreasing, and constant graphs. So how many hours you are away from a shuttle and the gas required to get there. Is this an increasing, decreasing, or constant function? Give me a reason for your answers. What do we think? Let's start with, is this increasing, decreasing, or constant? Tammy and Abu say increasing, so that's Jason. Let's hear what everyone else has to say. Okay, looks like everyone agrees. So this is an increasing graph. And if we think about our conditions, the first one is, it is an upward slope from left to right. So you can see this graph looks like it's going up if you look from left to right, right? And then if you look at the points, specific points, you will see that as the gas required increases, the hours away also increase. So that has to be an increasing function. No ropafazo, there is no coordinate that stays the same. Let's look carefully, okay? Let's check at 2. This coordinate is at about 3. So let's say gas required 2, 4, 6. So at 2, we have 3 hours. At 4, we have 5, about 7, right? And at 6, we have just over 10. We can maybe say 11. Can you see that? So as one increases, the other one also increases. And while we're here, is this a linear or nonlinear graph? While we're here, is this a linear or nonlinear graph? Tammy says linear. Okay, a lot of you say linear. It is, okay? A, you can check by constant difference. From 3 to 7 is plus 4. 7 to 11 is plus 4. That means we have a constant difference, right? And it is a straight line. So it meets both of our conditions. Okay. Okay, I thought I missed something, but I haven't. Let me move on. Next, is it increasing, decreasing, or constant? Is this graph increasing, decreasing, or constant? Increasing. Oh, Abu even added a nice feature, Angis. So it is an increasing non-linear graph. So it is increasing and non-linear. Yes, guys, increasing non-linear. That would be correct. Okay. So what I want you guys to see with these graphs is that the two properties don't depend on each other, right? It could be increasing and linear, but it could also be increasing and non-linear. It could be decreasing and non-linear. Okay. These properties have nothing to do with each other. You have to check. Yes, Abu, you should be very proud of yourself. You guys have to check each property on its own. You can't say because it is increasing, it means it is non-linear, because we don't know. You have to check, right? Now let's check with our table. We're back to our table. Is this increasing, decreasing, or none, or constant, excuse me? Increasing, decreasing, or constant graph? Remember, we're looking at our points. Jason says decreasing. Okay. Ropafazo says increasing. We have 2 more decreasing, and then Fonso says increasing. What does everyone else think? What does everyone else think? Tammy says increasing and linear. Oh, nice. Okay, let's look, guys. So the x's are obviously increasing, right? -2, -1, 0, 1, 2. So this we know is increasing already. Now let's look at the y coordinates. To go from -8 to -6, are we increasing or decreasing? And by how much? How much are we adding or subtracting? Tammy says +2. -6 to -4, +2. -4 to -2, +2. So we're definitely increasing. Okay, so if we're both increasing, then that would be an increasing function. And if you check, we have a constant difference. So then that would make this a linear graph. So this is a linear increasing function. You guys are getting very good at identifying these properties. Now let's look at these two. What's happening with these two graphs? Are they increasing, decreasing, or constant? Give me a reason for whatever you answer. Tammy says constant. What does everyone else have to say about this? Okay, Abu says constant. Adi says constant. Shulani. Yenzeka. Give me my reason, guys. Nobody has given me a reason so far. What is my reason? A, the coordinates stay the same. So these are two different graphs, obviously. Let's look at this one first. So the point over here is 1, 3. This one is 1, 0. This one is 1, -3. What's remaining the same? The x coordinates. Do you see that? So no matter where you draw a point on this graph, your x coordinate will always be 1, right? That means it is a constant graph. And if you look at this one, it's your y coordinate that remains constant. See, y is 3, y is 3, y is 3. So then your y coordinate, no matter where you draw a point, if I draw a point at -1/2, it will be -1/2 and 3. Do you see that? So this would be a constant graph. So the important thing to know is that you have two types of constant graphs. They can either be vertical, which is when your x is the same. Okay, so you need to pay attention to this. If x is constant, then this is a vertical graph. But if your y is constant, then this will be your horizontal. Thank you, Abu. If your x remains the same, it's a vertical. If your y remains the same, it's a horizontal. Wonderful. Now, we have graphs that do both, or all three. They increase, they decrease, they're constant, blah, blah, blah. Let's see what's going on here. This is a graph that shows the number of running shoes that were sold during a week. When is this graph increasing? When is it decreasing? And when does it remain constant? Palisa, yes, Palisa.
Ma'am, it increases from Monday till Wednesday. And then Tuesday it decreased.
Okay.
And then from Tuesday it increased until Friday. And then from Friday, it was just neutral.
Constant. Here we go. Palisa has given us a summary of the whole graph. So she says increasing is from Monday to Wednesday. Again, from Thursday to Friday. That will be increasing. Decreasing, you said it's from when to when, Palisa? Oh, Palisa's gone, never mind. She said from Wednesday to Thursday, it's decreasing. My handwriting is horrific. And then it will remain constant from Friday to Sunday. Okay. Guys, my handwriting was better than this. But I'll solve it. Don't worry, don't worry. Muni warini. Okay, so we're gonna do the same this time with Peter's run. Peter is running. Sinesihle.
Yes, ma'am.
There we go. Are you gonna tell us when it was increasing, decreasing, and constant?
Yes, ma'am. I'll tell you, ma'am.
Okay, let's hear.
So, ma'am, from 0 minutes till 40 minutes till 20 minutes, it increased by it stood at 5. And then
Okay,
from the distance 5 to 10, it increased by another 5 kilometers, and it stood at, and the time was 40 minutes.
So from 0 to 40, it is
20 minutes.
But is it increasing, decreasing, or constant? Increasing. So we have 0 to 40. What happens when it gets to 40?
To 40, it stays constant, ma'am. The kilometers.
Constant. From 40
to 45.
45. Then what happens from 45?
So from 45, it goes up to 60, and that would be 50.
So it is increasing, right?
Ma'am.
45 to 60. Then what happens at 60? Are you sure it's 60? Carefully.
Oh, it's 65, ma'am.
There we go. Then what happens from 65?
From 65 to 70, it stays constant.
5 to 70. Then what happens from 70?
And from 70, it stays, it decreases again.
There we go. So from 70 onwards, it is decreasing. Thank you very much. Now, guys, since we are interpreting graphs, I need us to discuss what this means. So this graph is telling us the distance from home that Peter is, right? So when the graph is increasing, what does it tell us? Now we're doing some difficult stuff, but I know you guys can do it. I know you guys can do it. When the graph is increasing, what does it tell us about Peter's running? What do we know, guys? Palisa, let's see what Palisa has to say.
Ma'am, I think it means that he was running at a steep at a steeper hill, I think.
No. See, this is why I'm doing this. So that
Oh,
we know
his speed was increasing. His
there
running
we
speed was
go.
increasing.
No, remember, what does this represent? The distance from?
Oh, from home
So,
in kilometers.
so the distance is?
It's 40. I mean,
It's increasing. It's getting further and further away from home.
Yes, ma'am.
You see that?
Yes.
Because at 0, he is 0 kilometers away, which means he's still at home. But
Yes.
in 20 minutes, now he is 5 kilometers away.
Kilometers away.
And at 40 minutes, how far is he?
10 minutes away from home.
10 kilometers.
10 kilometers.
There we
Sorry.
go. Now, let me ask you something. Between 40 and 45, the kilometers don't change. You see that?
Ma'am, please repeat.
Between 40 and 45, kilometers don't change.
Yes.
So what does that mean?
He had a break.
There we go. Guys, if the graph is not changing, that means he's standing still. So between 40 and 45 minutes, Peter wasn't running at all. He was standing still. Beautiful, Palisa. I love it. Are you
Thank you,
in
ma'am.
the for more challenge?
Yes, ma'am.
Okay, so we've established when it's going up, that means he's running further away, right?
Yes.
What's happening when the distance from home is decreasing?
That means he's going home.
He's running back towards home. Beautiful, Melissa. So when he runs further away from home, then it's an increasing graph.
Yes.
But if it's the other way, then it's a decreasing graph. And that sounds like a very cute baby. Thank you, Melissa.
Welcome, ma'am.
That sounds like such a cute. After I said that, the baby started crying. Maybe I should not speak about babies. Okay, guys, do we understand? Do we understand these graphs? Yes, Tato. Okay, if the graph is decreasing, it means he's getting closer to home. That means he's running back home. So from 70 minutes on, he was running back towards his house. But from 0 minutes to 40 minutes, he was running further away from home. When the graph is straight, that means the distance is not changing. So he stopped running. Okay. So if you ever get such graphs, at least you will know how to interpret. And I'm going to take Sinesitle's question. Then we can do the poll and then we can go.
Ma'am, I wanted to ask, if he was standing still but his minutes increased, what would be happening then? Or would he be taking a break?
It's straight, yes. Can you see here? Look at from 40 to 45. The minutes are increasing, but the distance isn't.
Yes, ma'am.
That means he's still in the same, he is still 10 kilometers away from home. So that means he stopped running. You see?
Yes, ma'am.
Yeah. Okay, guys, that would conclude my lesson for today.